Hello everyone, welcome back to my YouTube channel. So in the previous videos, we have seen bubble sort algorithm and its implementation. Now in this video, we will look insertion sort at a glance. So let's have a look at the algorithm of insertion sort. So in the first step, we need to start iterating the array from the second element. Note that you need to start from the second element. Now name the second element as chief and its current position as counter. Chief is the current element on which we will be working with. Now the third step is to compare the chief with its neighboring leftmost element, which is immediate to it, which means array of ith element will be compared with array of I minus 1th element. Now after comparing, there will be two possibilities. First is that the chief will be smaller than its left element. Now in this case, we will have to swap it, because we need our array to be sorted in ascending order. Now make a note that whenever we swap the chief with its left element, the chief would be now at the left element's position. Now this was the first possibility. The second possibility will be that the current element, which is chief, will be greater than its left element. Now in that case, we need not to do anything and we just have to increment the counter. Now we need to repeat this step again and again until and unless we reach a situation where the current element's position would be 0. Finally, we will end up with a sorted array. Talking about the advantages of insertion sort is that it's one of the simplest sorting algorithm. Compared to bubble sort, the number of swaps also decreases in insertion sort, which decreases the best time complexity. Also, it takes less space to sort. Disadvantage of insertion sort is that it is inefficient for large datasets because of more time complexity. Now let's have a look at the working of insertion sort. Here we have taken an example of an unsorted array of 4 elements 10, 7, 34 and 5. Now as per the algorithm, we know that we need to start with the second element. So in the past one, we have the counter as 1. So our second element, which is at index 1, is 7. So chief equals 7 and counter equals 1. Now we need to compare the current element, which is chief, with its left neighboring element, which is 10. If 7, which is the current element, is lesser than its left element, then we need to swap it. Now after swapping, we can see that our chief element is now at index 0. Now as per the algorithm, if the chief element reaches at index 0, then we need to stop. So now we'll increment the counter and now our chief element would be at position 2. At position 2, we have the element as 34. So 34 is the chief. Now we will compare 34 with its left element, which is 10. So now since 34 is greater than 10, we need not to swap it because it's already sorted. And if such situation arises, we need not to go further and we have to increment the counter. So in the past 3, we have the counter at index position 3. So at this position, we have an element 5. So 5 will be now called as chief element. Now 5 will be compared with its left element, which is 34. Since 5 is less than 34, we will swap it. So after swapping, it would look something like this. Now we will check whether 5 is at index position 0. If not, then we will again compare 5 with its left neighboring element, which is 10. Now since 5 is less than 10, we will have to swap it to get ascending order. Now again we will check whether 5 is at index position 0. If not, then we will have to compare it with left element, which is 7. Since 5 is less than 7, so we will have to swap it. Now after swapping, we will have 5 at index 0. So in this condition, we need to stop and go for another pass. So now we will go for pass 4 with index position 4. So now inside the array, we have the maximum index position as 3. We do not have index position 4. So in this situation we will stop, and therefore we have got our sorted array. In the next video we will implement insertion sort algorithm from scratch in Python. Stay tuned for that, and thanks for watching.